In this video, we're going to look at units and unit conversions. So in physics, we always work in SI units, and SI base units are really important. These are the fundamental units that we can make all other units up from. So the main ones that students are going to come across in GCSE are kilograms, meters, and seconds. Kilogram is a little bit odd because obviously we've got this prefix kilo, whereas every other unit has no prefix. The other ones are amps or amperes for current, Kelvin for temperature, importantly not degrees Celsius, moles for amount of substance, very rarely used in physics at GCSE, but of course used in chemistry. And then there's one of luminous intensity, the candela, which you've virtually never come across. So it's not too important that students know too much about SI base units, but what is important is they know that we always want to work in kilograms, meters, and seconds. Or if we're using derived units, so anything that is not this, one of these 7 units is called a derived unit, although it can still be an SI unit. Things like volts, pascals, watts, newtons and joules, for example. These are derived units. They are made up of a combination of different amounts of the, not really amounts, but different combinations of these base units. At A level, we look at this in a lot more detail. At GCSE, this is probably even slightly too much detail. I would say base units, they need to know what they are, and that these are made up of other things, other units. So we need to train students to, if they ever see something like kilojoules or millivolts or kilowatts or things like megawatts, they always need to convert these into joules, into watts, volts, and watts, for example. If they had millimeters, we need to convert them into meters. If we have grams, we need to convert them into kilograms. And 99% of the time, if students do this, it's the right thing to do. All right. Very occasionally, we will work in units that are not these base units here. For example, we might use grams per centimeter cubed for density. That's one of the few exceptions. Miles per hour is one of the other few exceptions, but it's always these. In chemistry, not so true. Grams we would use a lot. Because typically chemists are working with small amounts, but in physics we want these. I'm emphasizing this point a lot because it's a source of frustration. Students still struggle to convert units, and they lose so many easy marks on exams where they will be given minutes, for example, or given millimeters, and they forget to convert, and that's just such easy marks over a paper. That's 2 or 3 marks, which could be half a grade boundary. So students need to know that mega has a symbol M, is a million of something. They need to learn kilo, which is 1,000, centi, which is 100th, as in centimeter. They need to learn milli, which is 1,000th, and they need to learn micro, which is 1,000,000th, and then nano is also quite useful as well, which is 1,000,000,000th. Now, it could be the case that giga comes up, but it's unlikely. These are the most frequent ones at GCSE. So one way, of course, is just doing lots of practice and really reinforcing this, and that is a good method. But I'm going to introduce you to a slightly better method that does work well for a lot of students. It seems more complicated at first, but actually it does simplify things. So let's look at changing 3.7 kilometers into meters. So we need to train students to write down the conversion factor. So 1 kilometer is 1,000 meters, and we need to remind students that anytime you times anything by 1, you obviously got to get the same answer. So what we can say is we can say that 1 is 1,000 meters per kilometer, or I probably would actually say there are 1,000 meters per kilometer. Now we can times by 1, and we converted units and we've got the same thing. So all I've really done is taken this unit and I've treated it as some quantity, taken it over here. This thing with the units often is it is a conceptual leap too far for many weaker students, but if you just tell them to write down this conversion factor, they're usually a lot happier with this. So what we can write is 3.7 kilometers times by our conversion factor, which is obviously just 1. And what's that going to equal? That's going to equal 3,700 kilometers times meter over kilometers. You can see that these cancel and we've got our answer. Right? A lot of students will say, isn't this a bit of overkill? Have you not just overcomplicated it? And to some extent, we have. But the fact remains that students routinely struggle to do this. I still got year 11 say how many meters are in a kilometer, for example. So perhaps if we use this method right from year 7, we will be making students more able to do this, more confident and more capable. So let's look at another example. So let's go the other way. Let's say 265 meters into kilometers. So again, we're going to write down our conversion factor. Now we're going the other way this time. So we need to say there's 1,000th of a meter in a kilometer. So 1,000th kilometers for every meter. So now if we do our 265 meters and we times it by 1, which is our conversion factor, 1,000th of a kilometer per meter, then we can get our answer is 265, so 0.265 kilometers. So the way I'd probably phrase this to students is, what we're trying to convert from meters to kilometers. What is the conversion factor? There is 1,000th of a kilometer in every meter. So therefore, times meters by our conversion factor here. I would say what we're going from kilometers to meter. There are 1,000 meters for every kilometer, and that is our conversion factor. So basically, I'm saying this conversion factor in words. There are 1,000 meters in every kilometer. And here, again, I'm saying this in words. There is 1,000th of a kilometer in every meter. All right. And this really helps reinforce the fact that when we're dividing by something, that's the same as like per, or is the same as for every. So this is a really good mathematical trick. All right. 1 over 100 would mean 1 divided by 100, 1 per 100, 1 for every 100 of something, right? We'll look at one more example that's a bit more complicated. This is probably the hardest students would have to do, miles per hour into meters per second. So let's write down our conversions. Students don't have to remember this, they would be given this, but they might be asked to make this conversion. And they would, of course, should be able to work this out. So what can we say? We're trying to go from miles to meters. So we can say there are 1,600 meters for every mile. And we're trying to go from hours to seconds. So we can say there is 1/3,600th of an hour in every second. So now we're going to times our 60 miles per hour by our 2 conversion factors. Now I'm writing the units in because this is good practice, although I imagine students won't unless you really force them to. So now we can type this into our calculator and we get 26.7. And let's just check the units so I can prove to you that this works. So these are our units. We have miles here divided by miles here, so that cancels. We have per hour here, which means divided by hour on the top, so that cancels. We've got meters per second, so our answer is 26.7 meters per second. So just to summarize, if we are going from, for example, meters to kilometers, we would say, right, students, what is our conversion factor? There is 1,000th of a kilometer for every meter. So times your original number by this conversion factor. If I was going the other way, for example, kilometers to meters, I'd say there is 1,000 meters for every kilometer. Therefore, times your number by this conversion factor. And that will work for absolutely anything, whether it's kilojoules, millivolts, kilowatts. And it's a very important skill and is worth several marks on every GCSE exam.